Hey Sherwood, in this video we'll be looking at congruence standard 9 and the part of that standard that um, addresses proving that every point on the perpendicular bisector of a segment, so here's the perpendicular bisector of a segment, showing that all those points are equidistant from the endpoints of the segment. Alright, so in other words, if you pick a point like that, we'd like to be able to show that it's the same distance away from B as it is from A. And to really help you see that, let's take a minute and look at Sketchpad just for a second. Now, if you sort of randomly pick a point anywhere out there and you measure from A to B, okay, in general, you would expect to find this situation in which the point is either closer to A or closer to B. All right, so if you compare these distances, you see that this one is way closer to A than it is to B. All right, and as I scoot this along, you can see that it's always closer to A. All right, but there's a special situation in which those two distances are exactly the same. And that's when the line is a perpendicular bisector of the segment. And so that's what we're studying in this lesson. Okay, so with that being said, let's set out to prove this result. Okay, and so we're given that C is a point on the perpendicular bisector of AB, and we'd like to show that the distance from C to A is equal to the distance from C to B, just as you saw in Sketchpad a moment ago. We'd like to show that that's always true. All right, so let's make a flowchart to map out our thinking. It's helpful with proofs to begin with the end in mind and actually start at the end and work backwards. Okay, so we would like to do some work to show that CA equals to CB. And the way in which we'll go about showing that is we'll prove that these two triangles are actually congruent to each other, which looks true, looks like they're reflections, and they are. And so if we can somehow show that those two triangles are congruent to each other, then we'll know that their sides are congruent, and so these red segments will have to match. Okay? Now, how do we show the two triangles are congruent? We've got several options. We've got the SSS option. We've got the SAS option. We've got the ASA option and some others. But in all cases, we've got 1, 2, 3 measurements, whether they're sides or angles. We always have 3 measurements, and so we should set out to find 3 facts about our triangles in order to prove that they're congruent, in order to reach this conclusion right here. Okay, so that's just sort of a general overview of what's going to happen in this argument, and now it's up to us to look for those 3 facts and to figure out which of these situations we're in, and then we can just go from there. Okay, so in search of 3 facts, let's begin. All right, so a great place to begin is at the beginning. What's the information that we're given in the context of this problem? Well, we're told 2 things. Number 1, the line is perpendicular, and number 2, the line is a bisector. So let's take those one at a time. Okay, so line CM is, we're told, perpendicular to AB. So that's a fact about the line. And what does the word perpendicular mean? Well, it means that it intersects to form a right angle right here. So we can infer that angle CMA is a right angle. So that would be fact number 1. Fact number 2, besides the information about perpendiculars, we're also told that this green line is a bisector. So let's write CM is also a bisector of AB, and the word bisector means cut in 2 equal parts. So this is equal to that. In particular, from A to M matches from B to M. Okay, We got two facts. We need one more, and this one is just so obvious it's like staring you right in the face, which is that the two triangles share a common side. So side CM, the triangles sort of glued together right there. CM is common to both sides, and that's the third fact that we need. Okay, so let's recap. Number one, it's perpendicular. Number two, it's a bisector. And number three, they share a side. So let's interpret that. This is side, angle, side, matching side, angle, side. So we are in the SAS situation, and that's what's up. Okay, so the triangles have to be congruent by side, angle, side. Triangle congruence criterion. All right, so now we've done the hard part. We've proven that the triangles are congruent. And now for the easy part. If two triangles are congruent, then their corresponding sides and angles are congruent. And specifically, we'll want to show that the sides are congruent. So let's write that in. The sides are congruent. And in particular, side CA is congruent to side CB. And that's exactly what we were trying to show, is that these were equal. Okay, so what have we just done? We have proved that every point on the perpendicular bisector of a segment. Okay, and we've proved that these are the same. We've proved that CA equals CB, meaning that C is equidistant from the endpoints of the segment. In other words, this point here is equidistant from these points right here. That's what we've proved. Okay, now that was a lot of work. Let's kind of go back and fill this in a way that's more visual. With triangle congruence, you're just always going to see three facts being collected in order to get to congruent triangles. And then once you prove triangles are congruent, you can get information from that about the missing sides and angles that you didn't already find. All right, so let's just go ahead and fill this in so that you can see everything kind of on one screen and see that this is doable. All right, so here again, we have fact one. This line is perpendicular, so it meets at right angles right there. And so angle CMA must be congruent to angle CMB. And we'll make a note here that we knew that because those were both right angles, so they're both 90 degrees, and they must be congruent. Okay, fact number two, knowing that this was a bisector, so this line is bisecting this segment, therefore it cuts it into congruent parts. So AM is congruent to BM, and we knew that because the line is a bisector of the segment. Okay, and thirdly, we see that the triangles are joined by segment CM, so that's a common element to the two triangles. CM matches itself. Whoa, shocker. And this is just a common side of the two triangles. Okay, and with that, once again, we have side, angle, side, matching side, angle, side, and so the triangles are congruent by side, angle, side, and I'll make a note of that here. Why are they congruent? By SAS. In fact, this is the angle part, this is a side part, this is side, but the angle is actually between the two sides in the diagram, so it's SAS. And once you know that the triangles are congruent, it's easy to conclude that their corresponding sides have to match. So in particular, these sides are corresponding. If you picture the reflection happening across that line, you can see that they're corresponding, and so they have to match, knowing that the triangles are congruent. Okay, and that's our proof that any point on the perpendicular bisector of a segment is equidistant from the endpoints of that segment. I hope this is helping you to master congruence standard 9 from the Common Core standards for geometry students in high school. See you next time.